If you see the circuit diagram from variac, the power supply connection is going to the M terminal of the wattmeter. So you can see from the variac, I have taken it up where I have brought it into the M terminal of the wattmeter. Then if you see the connection diagram, M and C are sorted. From L it is going to ammeter and V is connected to the return neutral of the variac. So let us see, M and common are sorted. M are common are sorted. From L we are taking it to a ammeter. We are taking it to a ammeter. From ammeter it should go to the terminal 1 of the energy meter. So from the ammeter it is going to terminal 1 of the energy meter. Terminal 2 of the energy meter will go to the return of the variac. So you can see terminal 2 is going back to the return of variac. And another thing I told, V terminal of the wattmeter should return to the variac also. Here V, since here voltage are two voltage levels are mentioned, 150 and 300 volt, we will connect it to 300 volt because our energy meter is rated at 230 volt. Now wattmeter, if we see here, two current range is possible for this wattmeter. You can see 1/2 ampere. When it will be 1 ampere, if there are shunt plates are there, you can see this one, shunt plates of the wattmeter. This, if these plates will be in this position, that means it is representing lower current rating. And if we rotate it and make it parallel, these plates, you can see here I am making it parallel. Then in that case it will show the higher rating. Here itself you can see this one, it is showing if the links are placed like this, then it will be higher rating. You see it is written B1, B2 and E1, B1, E2 and E1, B2 are connected. Here you can see in this connection, you can see this one, here B1 and E2 are sorted and B2 and E1 are sorted. So that means higher current. So it is now in the 2 ampere setting and 300 volt. If it is 2 ampere setting and 300 volt, what will be the multiplying factor of the wattmeter? 2 ampere 300 volt. So multiplying factor will be 4. Okay. So whatever will be the wattmeter reading through the pointer or indicator we will get, we will multiply it by 4. That will be the total reading. Is it clear? Now the thing is that this is the wattmeter. Now if we come to the circuit diagram again, then terminal 4 from the energy meter will go to the load and 3 will go to the load. That means they will connect parallel to the load. So you can see terminal 3 and 4 of the wattmeter energy meter is connected parallel to the load. So this is the circuit diagram. So first we will perform the short run test. Short run test, what is the procedure? We will correspondingly, here you can see gradually I will increase the supply voltage, then this will start rotating. First I have not connected the load. You can see I am just injecting the voltage. First we will inject the 230 volt voltage into the system. You can show the voltmeter. so that they can understand that I am injecting 230 volt. You can show it to them, voltmeter. It is 230 volt. But since no load is connected, you can see bulbs are not glowing, so the disc is not rotating. But the moment you will see, the moment I will switch on the bulb, the disc will start rotating. You see, the discs are started rotating. So in the disc, you can see there is a black mark. The moment the black mark will cross this black mark, we will assume the rotation is going on. So in the long short run test, we will take measure time taken by this meter to complete 10 revolutions. What we will see? We will measure the time required by the meter disc to complete 10 revolutions. Through the stopwatch, we will measure that one. And here you can see the meter constant of the meter. It is mentioned 3600 revolution per kWh. 3600 revolution per kWh. So it indicates meter constant. That means this meter will register 1 kilowatt hour energy when this disc will complete 3600 revolutions. That is possible. So since we will take 10 revolution, then how much reading energy should be recorded? It should be 10 by 3600. 10 by 3600 kWh should be recorded. Because 3600 revolution will make 1 kWh, then 1 revolution will make 1 by 3600, 10 revolution will make 10 by 3600 kWh. That will be the test meter reading. For the standard meter reading, what we will do, you see the energy meter reading is mentioned here. How much is it? It is, you can see this is 90, then this is 100, this is 110, and correspondingly 120. Let us give some time for the indicator to settle down. This type of oscillation comes to the indicator if the control torque capability of the pointer has slightly reduced. But we can see, we will see that one. Before that, let us take the ammeter reading of the how much current is being drawn by it. 2 ampere means upper scale, so it is 1.4, then 1.5, 1.52, 1.54, and between 5.4 and 5.6, so 1.55. So what I will do is that I will write the corresponding ammeter reading is 1.55 ampere. Load voltage, how much is the voltage? It is upper scale 220, it has crossed, then maybe 220, but it has not crossed 230. So 220, 224, 26, around 226 volt load voltage. So voltmeter reading, we will write 226 volt. We will measure the 10 revolutions. So number of revolution we will make this one. Energy recorded for 10 revolution in the test meter should be 10 by 3600. I have just explained you. Two things I will have to note down now. Wattmeter reading, time taken. So let us give some time for the wattmeter to settle down. It is oscillating bit.